Welcome to this video on roots. Let's begin. So in order to understand roots, we first need to learn the notation. So this sign right here is called the radical sign. This number n is called the index. Now you might be the most familiar with seeing something that looks like this. So how do we read that? Notice that there isn't any number up here. So we read that as the square root of 4. How do I know? Well, it says it right here. It says when there is no index shown, in other words, there's no number written right here, then the index is understood to be 2. So you're probably the most familiar with seeing the symbol without any number up here. So we know that, for example, the square root of 4 is 2. We know the square root of 16 is 4. We know that the square root of 9 is 3. If this is not something that you know, that's okay, because this whole video is about finding roots. So sometimes we have a higher root than 2. So for example, I might write something like this. So this is the third root of 27. So again, this number up here is called the index. And then the number under the radical is called the radicand. This is not a word that I frequently use when I teach this, but if you would like to learn that, if you would like to remember that, you are welcome to do so. So the nth root of a means the number that, when raised to the power n, gives a. In other words, we're saying what number, this is a question mark, raised to the nth power gives a. So usually students find this a little bit confusing because we're talking about this in very abstract terms. Okay, so let's just take a minute and actually apply some numbers here so it starts making sense. Before we do that, however, I want to make a note that exponents and roots are inverse operations. That means exponents can be used to undo roots and vice versa. So you can see here we have a table of perfect squares, perfect cubes, and perfect fourths. Well, why am I looking at exponents when I want to use roots? Well, the answer is that knowing these and being familiar with these can help me find roots. So let's go ahead and move on to some numbers. So we have, first of all, we have the square root of 16. So remember, when you don't have a number up here, it's assumed that it's the square root. To help yourself remember, if you'd like, you could always write a 2 right here. So what the square root is asking us is, it's saying that there's some magic number. Some number times itself is equal to 16. Or another way to say it is some number squared is equal to 16. So notice that I've reproduced this table down here. So we're looking for perfect squares. So what perfect square, what number times itself gives us 16? Well, notice it's right here. 4 times 4, or 4 squared, is equal to 16. So therefore, I can rewrite this as 4 times 4 is equal to 16. So I can say that the square root of 16 is 4. So my final answer is 4. At this point, I'd like to point out and note that all of these things can be directly, simply typed into your calculator and evaluated. You don't have to go through all of this process. However, part of this course is understanding what you're doing, not just blindly typing values into your calculator. So the purpose of this video is to help you understand what your calculator does when it finds a root. So this next one, notice it is a third root of 27. So what we're saying now is that there's some number, some magic number out there, which when multiplied by itself 1, 2, 3 times, right, x times x times x, is going to give us 27. So since this is a 3, now I'm going to look at perfect cubes. Is there a number raised to the third power that gives us 27? There is, right? 3 to the third power is 27. In other words, 3 times 3 times 3 is 27, or 3 to the third power is 27. Therefore, we know that the third root of 27 is equal to 3. So our final answer is 3. How about the square root of 81? So again, now we're looking back at perfect squares. Is there a number raised to the second power that gives us 81? There is. It's 9 squared. So we can rewrite this as some number times itself is equal to 81, right? And then we know that that number is 9, or in other words, we can write it as 9 squared is equal to 81. Therefore, we say that the square root of 81 is equal to 9. So let's look at the next question. This says the fourth root of 256. So now we're looking for perfect fourths. And unfortunately, this only lists 3 perfect fourths, doesn't it? So it has 1 to the 4th is 1, that's not going to work. 2 to the 4th is 16, also not going to work. 3 to the 4th is 81. So unfortunately, in this table, it doesn't go far enough. So let's just try typing 4 to the 4th into our calculator and see what happens. Well, it turns out 4 to the 4th power is actually 256. So again, what this is asking is it's saying some magical number, we'll call it x, multiplied by itself 4 times, right? 1, 2, 3, 4 is going to give us 256. That's what we're saying. And then when we find out, the answer is 4. 4 times 4 times 4 times 4. Type it in your calculator if you don't believe me, is 256, or 4 to the 4th power is 256. Therefore, we can say that the fourth root of 256 is equal to 4. Our final answer is 4. Again, I invite you to remember, I can literally type directly. I can type in the fourth root of 256 into my calculator, press enter, it will give me 4. I don't have to go through all of these steps. I'm going through them now so that you understand the process and the meaning, the definition of a root. So the next one is the fifth root of 32. So once again, our table isn't really going to help us, is it? Because it only goes up to perfect fourths. It doesn't go up to perfect fifths. So again, probably what I would do if I didn't know what the answer was already, I would probably type this into my calculator. So what this is saying is that there's some number times itself, right? 1, 2, 3, 4, 5 of those, that's going to give me 32. So 32 is still a relatively small number. I know it can't be 1 because 1 times 1 times 1 times 1 times 1 is just always 1, right? So let's try 2. 1, 2, 3, 4, 5. Type that in your calculator and you will find, in fact, that it is 32. Again, you don't have to guess with this with these problems because you can type the fifth root of 32 into your calculator. And again, if you're not sure how to do that, either use the internet to find a video that will show you for your specific model of calculator, or ask your instructor and they will help you. So let's write our final answer. We have the fifth root of 32 is equal to 2. So my final answer is 2. Okay, the next one is the square root of 64. So what we're saying is that there's some number times itself is going to give us 64. So since it's a square root, we're back to our table, perfect squares, and we can see that 8 squared is 64. In other words, 8 times 8 is 64, or 8 squared is equal to 64. So our table does help us in this example, and we can rewrite, write the square root of 64 is equal to 8. That's our final answer. So on the last question, we have the sixth root of 64. So we have 1, 2, 3, 4, 5, 6. X's is going to be equal to 64. So what number is that? So one way to think about this is that x times itself 5 times is 32. Well, what's 32 times 2? Well, it's 64, isn't it? So we can use the fifth root of 32 to help us then build up. So 2 times 2 times 2 times 2 times 2 times 2, that's 2 to the 6th power. That's going to be 32. Again, you don't have to, I'm sorry, I apologize. That should say 64. There we go. Not 32. Again, you can just type in the sixth root of 64 into your calculator. You don't have to know these math facts. Your calculator knows them for you. Again, the purpose of this video is not to make you know all of these higher roots, is to help you understand the definition of a root and what a root is asking. So the purpose of this page is because many times my students get confused between exponents and roots. So for example, let's say a student sees the square root of 4 on an exam, right? And I don't know if it's because too much time has elapsed because since they studied or whatever, but sometimes students will write the square root of 4 is equal to 16. Is that correct? Absolutely not. right? So I'm going to teach you some basic principles that will help you remember and kind of fact check yourself when you have to do these on a test. Okay, so again, I've already said that exponents and roots are inverse operations. Since they have opposite meanings, right, then they definitely don't mean the same thing. So if I ask you to square something, that's the opposite, not the same as finding the square root. So if you take nothing else away from this video, I encourage you to remember that exponents, square, and the square root are opposite. They're going to take you in opposite directions on the number line, not the same direction. So let's fill out this little table. Did the number increase or decrease? So let's all agree that we started with 4, right? And then we squared it. 4 squared is 16. So did 4 increase or decrease? Well, 16 is definitely bigger than 4, right? So by squaring the number 4, we got a larger value. Again, you can pause this video, fill out the rest of the chart, and then unpause it and make sure you are right. In the next problem, right, we have 8 to the 3rd power. So we start with the number 8, we end up with the number 512. So definitely that number got larger. 2 to the 4th is equal to 16. So we start with 2. After we raise it to the 4th power, it became 16. Again, it is getting larger. So notice that in general, when we raise a number greater than 1, right, 4, 8, and 2 are all greater than 1, to a positive exponent, so 2, 3, and 4, those are all positive exponents, that will make the number bigger. So an easy, fast way to check yourself is that if you're using exponents in this course, right, and you have a base larger than 1 and a positive exponent, you should get a larger number than what you started with. If you, for example, were doing 4 squared and then you got 2, right, you got a number that's smaller than what you started with, you probably did something wrong, okay? So in this course, exponents are going to be making numbers larger. Again, that's not always true if your base is less than 1 or if you have a negative exponent, but we're not going to deal with that right now. That's far beyond what we want to do. So if we have a base larger than 1, we have a positive exponent, exponents are making things bigger. So let's talk about roots now. If I have the square root of 4, that's 2. So we started with 4, we took the square root, we ended with 2. So did the number get bigger or smaller? Well, it got smaller, right? Roots are going to make numbers smaller. Okay, so same thing here. We started with 8, we took the cube root of it, and then we ended up with 2. Again, our number decreased. Now we have the 4th root of 16. We start with 16, we end with 2. Again, our number got smaller. Okay, so when we find the nth root meaning the 2nd root, the 3rd root, or the 4th root, any number of root you want, okay, that's going to make numbers smaller. So as you're doing problems with exponents and with roots, ask yourself, did the number get bigger or smaller? And should it have done that, right? So again, if you're doing exponents, problems that look like this or this or this, right, you should expect your answer to be larger than the value you started with. If you're doing roots, like any of these 3 problems here, you should expect your value to decrease. It should get smaller. So if you are given a root problem and your answer is bigger than what you started with, you probably did something wrong. If you're given an exponent problem and your number got smaller, again, you probably did something wrong. Exponents, the ending value should be larger. Roots, the ending value should be smaller. So watch yourself, be vigilant, be careful as you do the exponents and the roots, and try not to confuse the two because, again, they have opposite meanings, not the same meaning.